The installation of a Cauley propeller on a Garret engine is a simple and foolproof process when you follow these simple steps. The procedures we will discuss here cover accepted practice for Cauley Model 600, 650, and 1100 propellers. After unpacking the propeller, make a quick inspection to assure that no damage has occurred in shipping. Also check that all parts necessary for installation are inventoried. The mounting surface must be clean and dry, on the propeller and on the engine flange. There should be a new A1633-57 O-ring inside the rear of the piston rod. Locate the O-ring and add lubrication. The proper lubricant for this job is turbine engine oil. The hub-to-prop shaft O-ring seal must also be new. If necessary, replace it and lubricate with engine oil. Be generous with the lubrication, assuring that O-ring seals are well covered. Observe the installation decal located on the number 1 hub socket. This contains information to aid in the installation. The blades should be in the full feathered position when you receive the propeller. This makes field installation easier. If, for some reason, the propeller is in the latch position, we'll use a slightly different procedure. We'll tell you how to skip ahead to a section covering latched propellers at the proper time. Meantime, follow these steps to mount either propeller. Hoist the propeller to the aircraft engine flange. Lubricate all attaching hardware and stud threads with Cauley lubricant A1637-16, or any lubricant that meets mil-spec T83483. Make sure the hub mounting flange and engine propeller shaft flange are clean and free of any lubricant. Mate the studs with the mating holes on the engine propeller flange. The studs should protrude through the flange just enough to install attaching hardware. Take care that lubrication is not on the mating surfaces. Start the nuts by hand and tighten just until the safety portion begins to engage. Seat the propeller firmly against the engine flange by pushing straight back. Do not allow the hub to cock on the flange. Make sure the propeller is seated firmly. Using the proper wrench, tighten all nuts until they are seated enough to hold the propeller in place. Remove the hoist from the propeller, moving it out of the immediate work area. Calculate the recommended torque carefully, using the guidelines provided. Be sure to double-check your figures. Serious damage can occur if the torque is not correct. Use a torque adapter such as Cauley's B5588. Torque all nuts in standard crossing sequence. After final torquing of each nut, mark the nut and stud to ensure that none are missed. Install the O-ring to the beta tube groove and lubricate with engine oil. Extend the lubrication onto the end of the beta tube, making sure an even distribution is obtained. Examine the piston rod. Notice that the threaded portion is clean and clear of obstruction. Carefully install the beta tube, taking extra care as the O-ring passes through the threaded portion of the piston rod. Turn the beta tube into the piston rod approximately 30 or 35 turns, using the Cauley tool B5378. Now we can check the flight idle angle setup. Position the power lever at flight idle, and run the unfeathering pump until the blades move to the flight idle position. But remember, the pump has a 90-second run limit that requires the next steps to be completed within that time. Otherwise, the pump will cavitate and the blade will move. The correct flight angle is specified in the aircraft maintenance manual. Check the angle on the blades with a blade protractor. If it isn't correct, adjust the beta tube until the specific angle is obtained. Moving the beta tube in, or clockwise, will decrease the propeller angle. Moving the beta tube out, or counterclockwise, will increase the angle. Continue to move the tube in and out until the proper angle is obtained. Now, pump the propeller to its start lock position by placing the power lever in full reverse. As the piston moves to reverse, you should hear a clicking sound. This will indicate that the locks are engaged. If the propeller you installed had the blades in the latch position, fast forward this tape until you see a red screen with the title, Setting Up a Latched Propeller. Play the tape from that point. When the reverse blade angle has been reached, turn off the unfeathering pump and move the power lever to the engine start position. The blades will automatically position themselves on the start lock. Install the beta tube lock and fasten it securely to complete the installation. Be aware, however, you should not attempt to lock wire the beta lock screw. This is not an approved procedure. Rotate the propeller by hand, a full 35 turns to return oil to the engine sump. Now, fast forward this tape past the next section. Stop at the red screen with the title De-ice block. If the propeller you installed had the blades in the latch position, follow this procedure. After the beta tube has been installed, position the power lever in full reverse. Start the unfeathering pump. Warning: don't let the pump run more than 90 seconds, or the sump will cavitate. While the pump is running, install B5021 Macaulay unlatching tools. After the unlatching tools have engaged the locks, turn off the unfeathering pump and position the power lever at the feather position. Remove the unlatching tools. Position the power lever at the flight idle position. Run the unfeathering pump for no more than 90 seconds. This will move the blade to the flight idle angle. This angle is specified in the aircraft maintenance manual. Check the flight idle angle on the blades with a blade protractor. If the angle isn't correct, adjust the beta tube until the specified angle is obtained. Moving the beta tube clockwise will decrease the propeller angle. Moving the beta tube counterclockwise will increase the angle. Continue to move the tube in and out until the proper angle is obtained. When the reverse blade angle has been reached, turn off the unfeathering pump and move the power lever to the engine start position. The blades will automatically position themselves on the start lock. Install the beta tube lock and fasten it securely to complete the installation. Be aware, however, you should not attempt to lock wire the beta lock screw. This is not an approved procedure. Rotate the propeller by hand, a full 35 turns to return oil to the engine sump. Clean the de-ice slip ring surface. Install the de-ice bracket and attaching nuts. Check the engine maintenance manual for the correct torque. Torque the attaching nuts until firmly seated. Install the brush block to the bracket using the proper spacers, screws, and shims. Adjust the shims to center the brushes in relation to the de-ice slip rings. Adjust the block to 60 thousandths of an inch short of making contact with the de-ice slip rings. Torque the attaching screws to 25 to 30 pound-inches. Add safety wire to complete the installation of the de-ice block assembly, and attach the aircraft wiring. It is necessary to make a final check of the flight idle blade angle with oil at operating temperature. Run the engine until the engine oil reaches operating temperature. Turn the engine off. After the engine is shut down, remove the spinner, remove the beta tube lock. Position the power lever at full reverse. Turn the unfeathering pump on. When the blades have moved off the locks, install the unlatching tool and move the power lever to feather, while turning off the unfeathering pump. Remove the unlatching tools after the locks pass over the tools. Warning: run the unfeathering pump no more than 90 seconds to avoid cavitation. With the pump running, position the power lever to flight idle. The blades will move to the flight idle angle. This angle is specified in the aircraft maintenance manual. Check the angle on one of the blades with a blade protractor. Locate the protractor at the marked blade reference station. If it isn't correct, adjust the beta tube until the specific angle is obtained. Moving the beta tube in, or clockwise, will decrease the propeller angle. Moving the beta tube out, or counterclockwise, will increase the angle. Continue to move the tube in and out until the proper angle is obtained. Now, pump the propeller to its start lock position by placing the power lever in full reverse. As the piston moves to reverse, you should hear a clicking sound. This will indicate that the locks are engaged. When the reverse blade angle has been reached, turn off the unfeathering pump and move the power lever to the engine start position. The blades will automatically position themselves on the start lock. Install the beta tube lock and fasten it securely to complete the installation. Be aware, however, you should not attempt to lock wire the beta lock screw. This is not an approved procedure. Rotate the propeller by hand, a full 35 turns to return oil to the engine sump. New spinners have a protective coating to protect them during installation. Refer to the installation decal on the bulkhead. You'll find important information and instructions there. Loosely install all fillets with the supplied screws and washers. Install an estimated number of shims inside the front support, and place the support on the propeller spring housing. Install the spinner shell over the propeller assembly and onto the spinner bulkhead. Check the attaching hole alignment. The spinner is properly shimmed when the shell attaching hole is within 1/2 hole of being aligned with the bulkhead attaching holes, as pressure is being applied to the nose of the spinner shell. Align the attaching holes and install all screws and washers. Remove the spinner shell and inspect it for corrosion, cracks, general condition, and front support damage. Manually inspect the blades for corrosion and damage in the blade retaining snap ring groove area. Look for oil leaks, face, camber, lead, and trail edge damage, and paint erosion. Special attention should be given to de-ice boots. If boot damage has occurred, the boot heating element may have been penetrated, causing damage to the blade. Simply because a boot continues to heat doesn't necessarily mean that there is no hidden damage underneath. If there is any indication of this, the boot must be removed and the blade inspected. Inspect counterweight condition and attachment. Balance weight condition and attachment. Visually inspect the hub for general condition and corrosion of surfaces. Attaching torque. Cylinder leaks and attachment. leaking from the rear mounting surface, spinner bulkhead attachment and signs of cracking, beta tube oil leaks, and lock attachment. Also check slip ring attachment and ring wear, brush block attachment and proper wire attachment, brush wear and alignment, and wire harness condition and attachment. Blade track is the ability of one blade to follow the other while rotating. Excessive difference between blade tracks, more than 150 thousandths of an inch, may be an indication of bent blades or improper installation. Here's how to check blade tracking. With the engine shut down, move one blade down vertically. Block up a smooth board centered under the blade tip. Make a mark on the board at the face side of the blade tip. Carefully rotate the propeller by hand to bring the next blade down. Center the tip over the board and scribe a pencil line as before. Continue this procedure with each remaining blade. Check that lines are not separated by more than 150 thousandths of an inch, 0.150. Propellers having excessively wide track should be removed and inspected. All blade repairs should, of course, be accomplished by a licensed mechanic, including lead edge repair, face and camber repair, and painting. The only repairs that a pilot or mechanic need be concerned with are sharp stress riser types of damage. This type of damage is caused by stones or other small objects striking the propeller blade as it is rotating. Erosion caused by sand, dirt, water, and other natural forces do not require repair in the field. Small object damage is normally found on the lead edge and face side of the propeller. To remove damage from the lead edge, start from the back and work toward the edge in a manner that the contours remain substantially the same. File strokes must run from the blade shank to the blade tip. Avoid abrupt changes in contour and blunt edges. The length of the blended area shall be equal to 10 times the depth of the nick. Use a suitable fine-cut file and coarse-grain emery cloth to remove damage. Then smoothly finish the surface with fine-grain emery cloth, crocus cloth, or 600 grit paper. Be sure not to remove any more metal than is absolutely necessary. The use of a coarse rasp file is highly discouraged, as they will remove more metal than is necessary, and may cause premature rejection of the blade at time of overhaul. Stress riser damage repairs may require a die check to verify that the damage has been completely removed. Propellers capable of reversing will have damage occur on the camber side of the outboard blade stations. To repair face and camber surfaces, use a handheld rotary grinder with 120 or finer grit bob, or by hand using coarse grain emery cloth. Use of a file in this area is not recommended. Be careful to keep the handheld grinder under control. Grind with a light pressure in a circular motion until damage is totally removed. The diameter of the repair should be 20 times the depth of the damage. Smooth finish with a fine-grain emery cloth, crocus cloth, or 600 grit paper. Prepare the repair for paint by wiping with an MEK dampened cloth. After applying a coat of iodine protection to the exposed metal, apply polyurethane enamel paint per manufacturer's instructions. Blend with the original finish. Turbine propellers should be checked for dynamic balance before returning them to service. To remove the boot, point the blade downward. Mask the hub and blade shank area to prevent solvent from leaking into the hub and damaging seals. Use a liberal amount of approved solvent, MEK or acetone, to soften the adhesion line between the blade and de-ice boot. Be careful not to use a metal scraper, which could scratch the blade surface. Starting at one corner of the boot, loosen enough material to grasp with vice grips. Remove the boot slowly and carefully to avoid blade damage. While continuing to apply a liberal amount of approved solvent to soften the adhesion, use a slow, steady pull to remove the boot. Discard the boot after removal. Use additional solvent to remove residual adhesive from the blade. Here is a simple procedure to install a new de-ice boot. Any bare metal must first be treated with iodine solution. Prime and paint all areas that have had paint removed. This must be completed before de-ice boot installation. Check the resistance of the heating element, making sure that it is correct. Gather the materials you will need. Adhesive, 3M 1300L is recommended, A1664-17 black enamel and A1664-18 catalyst for boot trim, MEK or acetone, and tackifying solvent. Tools include clean, dry, lint-free cloths, half-inch masking tape, 1-inch paintbrushes, 2-inch rubber or wooden hand roller, and a soft white lead pencil. First, outline the area to be masked using the white lead pencil. Mark it off by hand-fitting a de-icer boot to the blade. The boot must be centered on the leading edge, with the inboard edge located as shown here. Mark around the boot perimeter 1/2 inch from the edges of the boot. Outline this area with masking tape. Clean the entire masked area thoroughly with approved cleaning solvent. From final cleaning, quickly wipe off the solvent with a dry cloth. This eliminates any film deposits. Cleanliness of the work area, the blade and rubber parts cannot be overemphasized. Only completely clean surfaces can ensure maximum adhesion of the de-icer boot to the blade. Apply a second layer of masking tape to cover 1/8 inch inside of the previously masked area. Moisten a clean cloth with your solvent and clean the back of the de-ice boot. Mix the adhesive thoroughly. Brush a thin, uniform coat of adhesive onto the masked surface of the blade and onto the back of the boot. Allow the adhesive to dry. Cure time is about 1 hour when relative humidity is less than 75%. When the adhesive is dry, brush a second thin, uniform coat of adhesive onto the masked surface of the blade and the de-ice boot. When the adhesive is tacky dry on the blade surface and the de-icer boot, tack the inboard edge of the boot in the vicinity of the center line to the blade. The inboard edge must be at the location depicted, with the boot center line aligned with the leading edge of the blade. Starting at the shank end of the blade and working towards the tip, tack the de-ice boot center line to the leading edge of the blade. Use an approved tackifying solvent to keep the adhesive from getting too dry. When the boot is properly positioned, use the hand roller to press firmly along the full length of the leading edge for a tight bond. Carefully work a small section at a time, with your thumbs working from each side of the leading edge toward the trailing edge as shown. Now, gradually tilt the roller over each side of the leading edge. Use your fingers to work smooth any puckers of the material at the edges. When the boot is in final position and completely smooth, remove the inner 1/8 inch layer of masking tape. Do not remove the first layer yet. Before going to the next step, we need to do a final check of the electrical system. The resistance for the de-ice boot heater must be that called out in the aircraft maintenance manual. Check for resistance between the ground lead and the inboard lead if so equipped. Check for intermittent open circuits by applying light tension to the boot leads. There should be no fluctuation of any kind during this step of the test. If fluctuation is found, the boot must be removed and replaced. The purpose of the sealer is to prevent water from seeping under the adhesion line, causing the boot to work loose and creating corrosion on the blade. The sealer must cover the area of the blade exposed when the outer layer of masking tape is removed. Using 1/4 inch masking tape, mask off 1/8 inch in from each edge of the de-ice boot. Mix 2 parts of approved black enamel, such as A1664-17, with 1 part of A1664-18 enamel catalyst. Now, we are going to apply 1 even brush coat of sealer to the area around the boot. Brush the sealer in 1 even coat. Pull up the masking tape immediately after application of the sealer. It is important that the sealer not be allowed to begin setting up over the tape. Remove any remaining masking tape and allow the sealer to dry. In order to replace the brush block, the aircraft wiring must be removed. Remove the safety wire from the attaching screws. Remove the attaching screws, saving the bushings and shims. Install a new brush block using the original hardware. Adjust the block to the correct distance from the slip ring. Torque the screws to 25 to 30 pound-inches. Safety the attaching screws and reconnect the aircraft wiring. Feather the propeller to remove the feather spring housing. Remove the safety wire from the attaching screws. Remove the cap plugs from the assembly fixture attaching holes. Install and torque the E5011 feather spring assembly fixture to 72 to 84 pound-inches. Caution! This spring is under extreme pressure. Remove the attaching screws and back off the feathering spring. After the spring is completely relieved, remove the housing, spring, and assembly fixture. Remove all safety wire from the cylinder attaching screws and remove the screws. Remove the cylinder by pulling and striking lightly on the cylinder sides at the same time. Light taps can be applied with your hand or a rubber mallet. Any other tool can cause damage. Inspect the piston for damage, paying particular attention to the OD sides. If damage is found, the piston must be replaced by an FAA-certified propeller repair shop. Also, inspect the cylinder walls for linear scratches. If scratches have penetrated the cylinder wall plating, the cylinder must be replaced by an FAA-approved propeller repair shop. Remove and inspect the piston seal for damage and metal contamination. Lubricate a new seal with engine oil and install it on the piston. Remove and inspect the piston felt wiper for damage and metal contamination. Lubricate a new felt wiper with engine oil and install it on the piston. After lubricating the inside cylinder wall with engine oil, install the cylinder over the piston, paying careful attention not to roll or damage the O-ring or felt wiper. Check, too, that the backup ring is properly installed on the correct side of the O-ring. Install the cylinder attaching screws, replacing any that are questionable. Torque the screws between 72 and 84 pound-inches. Insert the spring housing into the cylinder and assembly fixture. Install the B5075 guide pins into the spring housing attaching holes opposite each other. Align the spring housing mounting holes with the guide pins and slowly, carefully install the housing to the cylinder. Remove the guide pins and install attaching hardware. Torquing screws 72 to 84 pound-inches. Remove the spring assembly fixture. Safety wire all cylinder attaching screws in pairs. Safety wire the spring housing attaching bolts. Be sure to safety the reverse stop bolts. Remove the spinner shell and front support. Remove the beta tube lock. Pump the blades to the feather position using the procedure discussed earlier. Remove the beta tube. As you remove the tube, oil will deposit in the cylinder and feather spring housing. This is normal and not cause for concern. Loosen the torque on all attaching nuts. Attach a sling and hoist to 2 blades to support the propeller. Remove all the attaching hardware. Carefully remove the propeller from the engine propeller shaft.